Hi again, Lee McWhorter here, a Starboard Security Instructor. This is the first video lecture for the new section of System Administration that started on 4/16/18. We have a lot of sections going. This has been my third back-to-back lecture today. And as you folks know, since you've gotten now through the first two classes in the program, these lectures supplement and support the course materials, so we're going to kind of do the normal model. I've got about 5 lessons to cover today for you guys and gals. And then, of course, next week we will cover the remaining part. We are going to talk briefly about some intro stuff initially, of course, and I'll try to point out some key things along the way. The main topic that if we get the time to get into at the end of this lecture today, I'll try to do a little demo on shell scripting, and if I don't get to it today, that's varied by timing of material and etc. But if I don't get to it, then I'll make sure I get to it next week. I can see notes from past times I've done this that I have had to do that occasionally, not make that get all that covered in the first day and end up doing some of that. This is a course that is not. I even had somebody ask me once, it's like, this course is going to turn me into a system administrator. Well, not by itself. It's not meant to be. This is a cybersecurity program, right? And so this course is meant to give you an overview of system administration so that as a security professional, you're aware of some of the system administration things, because, well, many times there's multiple reasons. One, it's a little bit of cross-training. Lots of times, especially in small organizations, you may be a system admin and a security person, right? That kind of thing. But of course, even if you have a dedicated security role, then you need to know what system admins are doing, because many of the times either you'll be overseeing what they're doing maybe, or auditing from a security point of view what they're doing, and or to helping develop policies and procedures toward what they're doing. And so this is an overview class so that you're aware of the concepts of the system administration as they pertain to security. And admittedly, some of these topics show up on, say, like the Security Plus certification test and things like that. So we wanted to make sure they were covered. And so this course kind of gives an overview of the entire sort of system administration world. And so, for example, we start with, I see what that is. Sorry, look at them. I'm getting lost by my own notes. So in an introduction to security, we talk about some key terms. We'll talk about some of the things that are some of the main roles and the responsibilities. We're going to spend some time talking about, which is a little bit more on some of the stuff you're already starting to play with, but we want to make sure if you didn't quite get it down, at least conceptually, or broader than just the use of the tools and network foundations, that you start to get these concepts in a broader use, which is cloud and virtualization and all this stuff. We're going to talk about network components. It's important to at least have an idea of the breadth and depth of all the different network components that can be out there and can be on a network, so you're prepared to potentially defend or use them for defense. We're going to talk about operating systems. It's important that you understand, in most of these days, it's becoming more and more common that, there was a time in the earlier days that Windows was pretty much everywhere. But in this day and age, devices run the gamut. Lots of people have machines. Mac's got a lot of popularity. More and more Linux machines out there, especially in the server world. They dominate pretty much now, especially in the cloud. So we're going to talk about all this. And then you are going to probably have a mixed environment wherever you go to work or to be a security person, because of the way things are these days. People bring their own phones. They got iPhones, Android devices, which we'll talk about in that section, are actually kind of, in effect, Unix devices. And so it's important to understand all the different operating systems, because you'll need to be defending them and maintaining them and using them both as clients and servers in different systems. And then lesson 5, like I said, we will get to and talk about, for many of you, maybe your first experience with programming. It's called shell scripting, and it is really, though, programming. I'm not going to lie to you. I'm going to be honest with you up front. Programming is not as hard as you think it is, especially when you start off with sort of easier procedural-driven types of things like this. So it's a good start. If you're comfortable with programming, it'll be easy. And if you've done some programming before, then this will be easy. But if it's new to you, then we're going to make sure you get basics of programming down as part of that, and then understand that shell scripting is a subset of programming using basically usually lighter weight languages built in or easily added to the operating systems in question, mainly so that we can automate tasks and do a lot of things from a scripted point of view. I always use the example actually of, I don't care how you do it. I can create a new user in Windows Active Directory, dialog boxes, new user, boom, and fairly fast I've got a new user. I can actually do it a little bit faster if it's a Unix machine with add user or new user or whatever the command is on the version of Linux, and run through those steps. And they're both pretty fast either way. We can do it, get a new user added in no time. But what if all of a sudden the company I'm working for, the boss comes in and says, hey, we just bought these guys. That's 1,000 users you got to add. You probably do not want to sit there and fill in that dialog box 1,000 times or even run that script on it. So there's ways, and many times we're scripting, especially in security. A lot of times we write custom scripts to do custom things for us. We want them to check certain things or consolidate certain things. We'll give you some simple examples to start with. This is not trying to turn you in. You'll get some more programming later in another class, but this is maybe your first experience. As we go on into the next week when we come back, for sure, if I don't get to the demos today, I'll do them to start with next week. And then we'll cover some basics of penetration and vulnerability testing. We'll cover secure protocols, secure network design, secure system design, secure deployment, and then we'll talk about the implications of embedded systems and the Internet of Things, which we've already mentioned in other classes, but we'll talk a little bit more about that. So that's kind of the overall of the whole course, of course. And so today we're trying to get through the first 5 of them for today's lesson. So in our intro to system administration, like I said, there's a whole bunch of key terms, and we bring back up the OSI model. You were exposed to the OSI model in the networking class, so this really should be a review for you. I won't spend a whole lot of time on that. But what is system administration, just when we're talking about that? Well, from the point of view of IT system administration, we're managing systems. And so systems can be broadly defined, though. That could be as narrowly defined as one server. Bill is the email administrator. He's the system administrator for our email server. That's what he does. That's what he does for us. It's a pretty full-time job. We got lots of people coming and going. He's got to do all the maintenance and backup and adding users, deleting users, etc. Maybe we have somebody else that's our webmaster, if you will. They're a system administrator. Of course, system administrators can be across the network. Maybe they run all the routers and maintain all that equipment. How it's divided across the 7 domains of the IT infrastructure, how it's divided amongst the roles within an organization is up to the organization. And we already talked in intro class about separation of duties and rotation of duties and security in depth and things like that. So you got to factor all that in, of course. But a system administrator, broadly defined, as someone who administers some system. That could be the repo of your software. He's an administrator, she's an administrator. It could be that the mail server. It could be the whole intranet, the local area network, all the equipment. However it's subdivided, those are the roles. They're the people in IT that maintain those systems. They're not help desk people generally. They're usually a little higher than that. They're not necessarily management, but it could be somewhere in the middle there. So kind of an intermediate position. And system administration is really involved with mainly 2 really big areas. One is to install and maintain systems. And so if that person is in charge of that mail server, or somebody's in charge of all the workstations in the sales department, or all the workstations of the company, then it's their job. When somebody gets hired, they set up a new system, they follow all the procedures, they patch it up, they put on the security software, they set everything up by they're following, maybe the security person helped design those policies of how this system administrator is rolling out this new client desktop to that user. And of course, the security person has helped design the policies that employee is going to have to follow, their acceptable use and password policies and other things. And so the system administrators will usually install new equipment and then maintain it. And they will, of course, be attempting in there, even if they're not dedicated to the security team or even don't dual hat, part system admin, part security team. In a sense, they actually, almost all of IT is really, in my opinion, part of security, even if you have dedicated people in a large enough organization, because that's the other big piece of what system administration is to secure and defend it. If you really are big enough of an organization that you have, 50 IT people, running servers and client devices and networks, and you've divided them up. They maintain, they manage. They're system administrators, some help desk people, some managers, but it's the core of these people that have these different responsibilities for different areas of that big old organization. And there's a dozen people over here in security that are responsible for, overseeing that from a security point of view. Maybe specialized equipment they may be responsible for instead of just average daily system administrators. But all these system administrators, the one managing the mail server, the one managing all that client, if they don't do their first job of install and maintain correctly, then we have a problem. We have a hole, we have an impact system, and that's a security vulnerability. But of course, and then if they don't maintain it, they don't keep it secure, they don't help defend it, once again, by maintaining all those proper things, changing default passwords, following procedure, then we can have a security problem. So doing their jobs right, even if they're not part of the incident response team, even if they're not part of the security team, even if they're not a security analyst or security system admin, and they're just implementing the policies and procedures put in place by the security organization, they're still part of the security team, and we should make sure that we audit that. We make sure they're doing what they're supposed to do. They're following the right procedures, and that we train them appropriately. And so they're going to be very much part of securing and defending all of our systems. Some best practices are covered in that lesson. Shouldn't be surprised. There are certain ones that come back again and again. It doesn't matter if it's the best practice for system admin or if it's the best practice for, setting up a particular piece of equipment. There's certain things that are just common sense. Use a password. Don't use the default password. Do certain things like that. But there are some really specific ones that are useful within the world of system admin. And actually, I believe in just about any type of system management and IT security even, which is like things like have a fallback plan. Don't roll out some major change to your organization's network or systems or servers without having a way to, fall back. If you can't undo what you just did and it's wrong and you've now screwed the entire organization's network up, then obviously you're going to be working late and trying to fix things at least, and you could be out of a job, or the company could be in trouble. Sorry about the barking dog. It's starting to get me a little bit here. So anyway, but go through those. That's the first chapters are always pretty straightforward. I want to spend a little time talking about the next chapter. Some of this you're already starting to get a picture of, and you've already started to play with some of these tools. Network Foundations was very heavy in virtualization. You were working with one of two things. You were either working with GNS3 and thus the GNS3 VM in the background, or you were running just virtual machines in VirtualBox, like an Ubuntu 14 or 16 or whatever version you were running to do different assignments. As I've said in other videos, and I'll say again, never the twain shall meet. We either do GNS3 and we're thus running the GNS3 VM, or we do stuff in standalone virtual machines just in VirtualBox, and you'll end up with a bunch of virtual machines, and you'll end up with a bunch of different networks and stuff inside of GNS3. They're all running really underneath via VirtualBox. They're all virtualization. And virtualization is hugely, hugely important to really start to get down. If you are having some difficulties with the previous class, this is a time this is a lighter class. You get to play with some different tools. You get to look at some of this. Some of this this will be a light lesson for sure because you've done most of this. This is actually something that I'll modify slightly probably in the coming revision, because initially System Admin went before Network Foundations at least a few times in the cover of things, and so we had to at least cover some of this. But it's still important because virtualization not only is useful for like what we're doing in this course, in these courses where we can play with these virtual networks and we can set up virtual networks, we can attack virtual networks, we can attack machines, we can defend machines, we can do all this in a virtual, in a safe environment, and we can learn on our own, and you get to keep and play with all these for years to come. It's also really what's powering a lot of what's going on in the world. When you hear the phrase cloud, for example, cloud is really, there are variants, and I shouldn't overly simplify, I guess, but the biggest component of cloud as it exists today is actually really nothing more than spinning up or launching or running virtual machines on somebody else's stuff. That's really all it comes down to. You literally could build a virtual machine in VirtualBox on your desktop, tweak it all up, customize it, make some custom version, whatever you're doing, a server that only is for you and your company. And then you could literally deploy that virtual machine to the cloud. You could make it an image and then run it. And just like you're running a virtual computer on your machine, and hopefully you've got a nice machine, it's a new machine with lots of RAM, and you can get away with that. On some of my older machines, it starts to press things to try to run too many virtual, because obviously you only got 4 gigs of RAM, but you're running half a dozen virtual things inside of a GNS simulated network, for example. That can slow things down. But when you talk about running it in the cloud, now we've taken this server, and the best we had was whatever our computer. If we had given every bit of our computer's resources to it, then our computer's hardware would be the limit. And if we were to go and build a real server, we'd have to buy, we'd have to decide, well, how much processor do we need? How much RAM do we need? How much all this stuff do we need? And that's what people did for years. But now what you can do is you can spin up a virtual machine in the cloud, and then you are paying for what you use. So if you launch a new website for a new company and it doesn't take off, you don't pay a whole lot. And you may have instead gone out and spent, like when I ran a company in the .com days, we spent tens and tens and tens of thousands of dollars setting up our own little data center. We got Cisco switches and routers, we got our firewall, we got some nice Dell servers with RAID arrays and redundancies, and we had multiple connections coming in from the internet. So we had no single point of failure, because we were the worldwide host for a company that was a global startup. It started officially in Europe, and then we were the US operations, but of course tech was more advanced here, and bandwidth much cheaper, especially in Austin, where I was based at that time and based now. And so we were able to we built the data center, and we ran it, we hosted everything for the whole company. If I was doing that today, I wouldn't go spend all that money. I don't think we wasted, thankfully. I think we were pretty smart, and we designed when we built those systems so that they could scale. We could still put more RAM, and we could put more hard drive, and we could try to grow. But let's just say hypothetically, we had one of those 1 in a million viral, one of our sites or one of the projects we launched under those .com days had really taken off. We might not have been able to meet that load. Our machines weren't that powerful. We didn't expect 1 million to hit visitors a day. We kind of planned for a realistic number and built our hardware that way. Today, startups can spin up their servers in the cloud. And if they get a lot of hits, hopefully they're making money, because they're going to pay a lot because they got all that traffic and hits. But if they don't, they don't really pay much. I mean, I've seen prices for running, small, simple little VMs for just dollars, sometimes pennies, dollars a month. And so instead of having to go out and spend all that hardware and do all that upfront money to build your own data center, you can build it all virtually in the cloud these days. And it's one of the things that has led to some of these explosive companies we now are even taking for granted. Many of the companies that that are big names today, Netflix, Uber, others, they have built themselves by powering off the cloud, by being able to use data centers all over the world that other people have set up, Amazon being the main big provider of all that. And they have, of course, huge resources. And so if you put your virtual machine there, just like if you ran one on your own laptop or your own hardware, your own computer, at some point you're going to run out of resources. If it was really, say, out there getting traffic at some point, 10,000 hits a minute, 50,000 hits a minute, 200,000 hits a minute, whatever it is, you finally just wouldn't be able to cope. Theoretically, on the cloud, you can ramp that up. You can scale up. You can spin up more copies. You can spin up copies in other parts of the world, and you can become just like Google and have copies of your site all over the world, spun up in different locations, different regions, and thus be able to serve that demand. Use load balancers to spread it depending on where they're coming from, and it's all seamless. When I ping Google, it pings a place in Dallas. Wherever you ping Google, I guarantee you not, unless you're here in Texas. And so unless you're if you're in another state, very likely you're getting a different result. But we both typed ping Google. But of course, it's all being handled and routed and balanced out across all their data centers, and Google runs this. Amazon got into this business because think about what they do. They had to build enough capability technology-wise just to make sure they could handle from Thanksgiving to Christmas, because that's like any retailer's biggest shopping season, right? That's where they make whatever, 30, 40, usually maybe majority of their money is during that one period of time. And so when Amazon is just getting slammed through the Christmas time, then they have to be ready. So they had to build data centers and processing to handle that many orders and deal with it. But then most of the rest of the year, they were sitting on that much hardware that they didn't have any need for. they weren't running, they weren't running a tenth of the regular traffic, during the average month that they were, of the peak traffic they get during the Christmas time. So they started selling that extra capacity in the cloud, basically to people so that they could run their machines. And whether that's somebody who's crunching numbers on a big simulation, whether that's in Netflix storing their videos and serving them from different places all over the world so they, they reach the right people, whether that's just a startup firing up a VM cheap so that they can put up the latest game or latest app, database servers, anything that we could run. Now, there are disadvantages and advantages to cloud, including, of course, a lot of security issues related to cloud. But nonetheless, it's very important you understand that basically cloud is virtualization. And there's different types. There's software as a service, there's platform as a service, there's all these AaaS. And this company is considering its Wazoo is part of being EAS, education as a service. Everybody wants to move toward this cloud model, and in many cases, what we're really seeing is that the world is sort of evolving into a hybrid model where people are deciding, organizations are deciding that they keep certain things on premises. They still want to control their server. They still want to control their customer list or their source code or certain things. But then you've got lots of, and then other things they put in the cloud, their websites, their public information, support sites, things like that. And then other people, though, have gone completely cloud. There's companies that have their entire source code in the GitHub repository. They've made it a private one if they're not open source, but if Git ever gets breached, then a whole bunch of software is going to potentially be at risk. And so people make different decisions, but these services are really empowering a lot of the new things we're seeing. It makes it so easy to spin up. And so it's important to understand virtualization, how it powers the cloud, and how we use it as security professionals. We're using it in the courses like you used in the last course. You were building virtual networks and setting them up, getting them to ping each other and giving out IP addresses and setting up firewalls and getting the basics of that covered, and building virtual machines and learning how to work at the command line and configure IPs and run software, install software, log in, things like that. Because once you know those, then they carry everywhere. I don't care if you're physically sitting in front of a Unix box. If you know those commands and you've now gotten down if config and all this basics, and somebody sets you down and says, here's a terminal, this computer is in Chicago in the cloud, doesn't matter. It's no different than running the VirtualBox or running the GSN3. You're at a terminal. Start doing your work. Do what you do. And so it's so beautiful. That's one of the reasons Linux taken over. It's free. And so even Microsoft Azure, their website, their cloud service, has been selling, and a good chunk of the money they make off of that is Linux virtual machines that they're hosting for people to run websites and database servers and whatever it is their application or company needs. And so it's hugely important to get this down and to get past just these are tools. They're not only tools that you're going to get you through this program, these are tools you're going to use the rest of your career. You're going to be working with virtual computers from now on. You will make your own virtual machines for whatever those reasons are. For testing, you definitely want to do this when you're in the field. You're going to, bring in a new set of equipment. Let's not just bring in a bunch of boxes and throw stuff on our live network. How about, vendor, that you give me an image or you give me the software? I'm going to put this in GSN3. I'm going to set it up so that I can test how it works with my other equipment. I'm going to, try out a different version of whatever flavor of Linux we're using that is behind our websites. We don't want to just roll out and break every site because there's some conflict between that new OS or that new PHP, so we can test these in virtual machines. Now, I love the virtual world. It just makes things so much easier. And I remember it used to be, I worked at one company and we literally physically had one Windows machine or one Macintosh machine that we kept literally doing nothing 90% of the time except sitting there in a static state of the latest. They were on automatic update. And so anytime it was time for Macintosh, Apple to push out or Windows to push out an update, they happen to those machines automatically. Believe it or not, even though it's generally good practice, there are exceptions. And as long as you know what you're doing and you take into account for it, we did not have our whole network on automatic update actually at that time. And there was a reason for that. And that is because we had seen automatic updates on one end or the other break things too many damn times. Microsoft pushed out an SMB, server message block protocol update, that killed all of the Windows machines' ability to see the Macs out of our network. And we've seen Mac do the vice versa. So we actually had it so that whenever the patch days happened, anytime a patch happened, we would go run a battery of tests against those machines. And then, of course, if everything was still working, you could hit the font server and get to our servers and hit everything, and everything was working fine. Then we'd roll those out, very shortly to get the most up to date, especially if they were security patches. But we didn't just roll everything out. We rolled things out in stages after we had tested. But we literally had one of each type of computer that kind of mirrored the average Mac and the average PC we had in the entire office sitting there, just so we could test that. Now we do it with a virtual machine. We have lots of virtual machines. We can test entire networks. We can simulate thousands of nodes attacking or doing something. And so you're going to use these tools to try things and to test, and to, not only to learn, but to continue to learn as you lifelong learn in this field, and definitely in your practice. There's no reason just to throw something wildly onto your network. You can use these tools to test it out. So there's a little bit of talk about type 1 versus type 2 hypervisors. We're using in VirtualBox a type 2. It runs on your machine. It's just a program. It's a Windows or Mac or whatever program that then provides that virtualized environment. And really what it comes down to, if you haven't quite figured this out on your own, is that on your hard drive, there'll be a folder created that'll match the name of the virtual machine you're creating. And inside of that folder will be a whole bunch of files. And if you start looking at them, you'll see that some of them are basic. One of them will grow as you put more and more stuff on your VM, because it's the virtual hard drive, or maybe there's a handful of files numbered sequentially, that there is a way to either have one big virtual hard drive or split them into smaller, so that you can transfer them on, say, like a USB stick or something, so that they don't get too big. But anyway, you will have that there's a file in there that's the memory. There's the configuration file. But as far as that running virtual machine is concerned, it sees it has, like I have 4 processors on my main machine, and many times I only allocate 2 to a virtual machine, because I don't want it to, obviously, one virtual machine to slow down my entire, and many times if it's a smaller one and I'm wanting to run multiple, then I may only give them 1. But so if I go into that virtual machine and I do, look at the system stats, it's going to say 1 processor, even though it's on a computer with 4 processors. The underlying operating system knows there's 4, but the virtualization has only virtualized 1 to that machine, and only maybe 1 gig or 2 gigs of RAM instead of all of my RAM, of course. And you can set these things. So we can set these settings. And this, even though you do it a little differently, the results are the same in the cloud. If you spin up a VM, that's what you're paying for. How much RAM does it use? How much space does it use? How much bandwidth does it use? And so you'll want to balance those things. But like I said, you can spin up one, and then you can let it grow and dynamically, spin up other copies, or assign more processors, give it more power as you need to, and thus you pay as you go. We also, and then of course there's bare metal, which is, if you, and this you will see, it's something that I've been starting to do with my own on-premise stuff, and I want to continue down that path. Instead of having dedicated servers, I like the concept of using virtualization myself. Because let's think about a typical type of, I'm not using myself, I'm just using a kind of made up example, but you have an example of an organization that has, let's say they're going to do everything on site. They don't trust the cloud. They're old school. They want to run it all here, and nothing wrong with that. So we're going to build a box that's going to be our mail server, our email server, our email server, our web server. We're going to get us a router and a firewall and some intrusion detection, and we're going to have another router and firewall further back to protect the network. We'll have all of our client, our systems back here, and we're just going to do it, no cloud involved at all. And well, that doesn't mean we wouldn't want to use virtualization. Because if we go and set up, just thinking of what's out here, the public stuff, we have to have 2 servers to be DNS. Ideally, you need at least 2 DNS servers. One is the primary, one is a backup. Many companies will have as many as 4 or more. So we have 2 servers that are DNS. And since one's supposed to back up the other, it's not like you would want to have them, you really want them to be physically different machines, or even if they're virtualized on physical different hardware, so that if one's down, the other's up. That's the whole point, as you have that DNS. So we got 2 pieces of hardware now, DNS servers, and they're separate. And we got a web server, and we're going to just keep things simple. And we got our email server. So we got 4 computers with multiple processors, with RAM, with whatever. Now, we may not really need to have 4. And if we look at all 4 of those, and of course 2 of them are DNS servers that really aren't doing much but just giving out IP addresses. Oh, here's my IP address, here's my IP address, here's this IP address, whatever. It's just small little bits of text and numbers going back and forth. I've run DNS servers for years. They do not take much load. So if you've got a machine that's doing nothing but being a DNS server and it's got all kinds of RAM and hard drive, it's running at no load. It's hardly using any processes. I don't care if you have thousands of people hitting it for DNS. It just doesn't take that much load. And so, and then your web server and your mail server, they may be busy at certain times, but not other times. And so one of the reasons virtualization is so valuable and started happening before the cloud inside people's environments, and why VMware and VirtualBox have been around for so long, is that people realized that they could put 3 or 4 of these types of systems on one big box and spread the load, and thus be able to, now like I said, you wouldn't want to put your DNS1 and your DNS2 on the same system, even as virtual systems. That'd be more efficient running. Instead of having 1 computer or 2 computers with only running at 2%, now you got 1 computer running at 4% capacity, but if that 1 computer goes down, you lose both your DNSs. So, but you might be able to, for example, like in a system, let's say we got, a couple mail server, we got a mail server and a web server. Maybe we have another web server that's like for clients only, a login one versus the public one. So we've got another machine now. Maybe we have some kind of file transfer or Dropbox or, a remote access VPN server or whatever. So now we're up to a half a dozen machines. And if once again, at the highest, the 2 DNS servers run 2 to 10% at any given time and never get beyond that, then all that extra processing and memory that they have is going to waste all the time. And then your web server may have peaks at certain times. Maybe your clients are busy on during the day, but then at night it doesn't go very often. But maybe you do a lot of mail blast at night. So you start to look at this, and then you build virtualization yourself within your own network, and so that you can balance that. So if we had a website that was busy during the day and a mail server busy at night, and neither one would by themselves get above 50%, let's put them together so that machine both day and night is running at 50%. And now we're getting and we're only using 1 machine to run 2 different systems. And the systems can be smart enough that we can give more resources during the day to the web server, so it's responsive, and then at night when we do our mail blast, we can give more to the mail server. And we might be able to spread those 6 or 7 or 10 machines across just 2 or 3 physical pieces of hardware running as virtual machines. And we can, of course, mix the cloud in there too, and that's once again virtual machines. So virtualization allows you to get much more efficient utilization out of hardware resources and better match hardware utilization to hardware usage. And especially in the cloud where you just totally exempt yourself from it, that's their problem. They're going to build all the they're going to have banks of hardware and hard drives and servers and memory, and I can just tap into what I need. The last few things in this lesson are you get to play with some of this stuff. You're asked to set up play with some of these tools. You'll download your own copy of Cisco Packet Tracer. Packet Tracer is very much like GNS3, except it's a standalone, and it truly is a simulator. So if you tried to go into that and you dragged in some stuff, it works like GNS3. You build topologies, but it only has Cisco stuff in it. But that's the reason you at least get some exposure to Cisco. It's one of the biggest brands out there. The VYLS router runs very much like it. The command, show interfaces, stuff like that. That's why we picked that one. But this lets you play a little bit with Cisco. And but it's only Cisco stuff, and it's only a simulation. It's a program. There's no VM running in the background. There's no VirtualBox. So if you tried to type some weird command that might be in the Cisco manual and would work on a real Cisco equipment, if it hasn't been programmed by that programmer, then it won't run. It'll give you an error message. Whereas you don't run into those in GNS3 because they're true emulations. Even if you're running Cisco equipment and have the license to do so in GNS3, you're running an emulator. But the Packet Tracer allows you to do the basic stuff, and it's a neat tool for demonstrating topologies. And if you need, to learn a little bit about Cisco along the way as well, then that's a good tool. Of course, we've already played with GNS3, and so, but then there's also, some more knowledge of the cloud stuff, especially if you have to do the extended exercises. So then let's talk about network components. There are tons of network components. Basically, anything you can plug into a network these days, we can broadly call a network component. So we, of course, if we kind of work from the outside in, we would start with like firewall, router kind of things. Of course, these are like, let's even keep it simple, like your home. All of us are pretty simple. We have some device that our provider has given us. Most of the time, it's either say an AT&T, a Comcast, TW, Time Warner Spectrum Now, whatever, whoever it is, there is some connection from the wall. It might be a phone line DSL type of connection if it's that technology, or it's a coax cable, like the cable type of technology. Regardless of which cabling format, that's at one level of the OSI model, right? Then it connects into some device. And that device, many times they call them modems. That's old school, but they're routers. Is what they are. Even a cable modem is a router. But basically, what it does is it takes the signal that the cable sends down, the coax cable, or the signal that's sent down the phone cable, and turns it into the cable we send down a network cable or over Wi-Fi. That's what routers do. They route between the different interfaces. And so that's all it is. It's a router. You get it. You have a router at home. You have nothing else. Many people, of course, take that device and then plug their own into it, and maybe we take up another capacity. But a lot of people, that's it. You have one box from your provider. That is your router. It's your firewall. It's your Wi-Fi access point. It's all things rolled into one. It's sort of a hybrid or multi-factor, multi-function component. But then you can still get individual components. So you can get just a router. You can buy a box, a Cisco or something else but many of those though, then inside have the ability to do other things. And so you have to make decisions. Sometimes you decide you want to use the router and firewall functionality in the same device, or maybe you break those into separate systems. Once again, as we've talked about in earlier classes, it's all part of your layering and diversity. You might use them from different vendors. You might have different layers of them, different setups. And so there are all types of network devices, of course. Some common ones, routers, switches. We have, of course, other types of servers, like especially once again starting at sort of the edge. We have things like filters. We might have filters that filter web or email traffic, proxy servers sometimes, as they're called. These can be done for any number of reasons. Many times they're done to speed things up. If you have a huge organization, say like a Dell or something that has 10,000 people in an area, so many big headquarters, a campus, whatever, then instead of having every time somebody, say at lunch, tries to go surf to CNN or some news site, instead of having that traffic go all the way out to that and get an answer right back to that individual, many companies set up a proxy server. And so when you try to go out to the web, you're really asking this server on the edge of that company's network to go get that web page. And then, of course, if somebody else 5 seconds later says, I need CNN, well, it won't have to go across the net. It'll just deliver the copy. It's cached. But it also can filter and check and make sure you don't go to sites you're not allowed to. We can filter traffic coming in like spam filters to see if there's attachment, if there's a virus in the attachment or bad links in it, or if it just looks like a standard Viagra ad, and so we're going to block it. And so there's all these different devices that we can use, which are practical, functional devices. But of course, as you can see and think about, many of them have security implications. All of them do if they're publicly accessible, because they could be attacked themselves. But all of them have implications of how you could use them. Obviously, if you filter spam in, if you can filter it out before it comes in, then you've cut down the chance that some spearfish attack or some Trojan is going to get onto a client machine in your sales department, right? So we want to know about all those different kinds of devices. And there are a ton of devices, though, and you'll spend a lot more time on these in later courses, but that are specifically security-related network components. Intrusion detection, IDS, or intrusion prevention systems, which are in many cases one and the same. Even in the one we use, Snort, we mainly use it as an intrusion detection, but the only thing that you would have to do to push that further would be to just take action based on it. Instead of just detect and log, you take action. So, an intrusion detection system, truly, that's what it does. It sees something based on some kind of rules and says, I see this weird traffic. It's too much for this hour. Maybe it's compared to a baseline, or it just looks like a known kind of attack, or it's some rule like we know we don't use these ports, so why is somebody trying to go to those ports? And so whatever reason it's kicked an alert off, then it detects it and tells you, and gives you a detection. If you go further with prevention, or you basically have those detection rules take action by, say, blocking a port, and this is particularly powerful if you combine devices or have, build a system. Even if you have a firewall that's separate, there's ways sometimes that, by putting, say, an intrusion prevention system in line, so it's in between physically the firewall and the server. So if something's gotten through the firewall and this intrusion detection sees it, then it can block it. it can drop that traffic so it never makes it to that server. And that then becomes more than detection, it becomes prevention. And there are all kinds of other systems. We're going to spend some time in the logging and monitoring cost talking about particularly NSM, which is Network Security Management, SIEM, which is Security Incident and Event Management. And then we're also going to talk about things like Unified Threat, UTM, Unified Threat Management, and et cetera. And then there's even a piece of that equation, or sometimes some of this is it used to be real simple where everything was like almost everything was its own device. But now today things are getting more and more multi-function. So there's these things now that they call next generation firewalls, which are basically firewalls and intrusion detection and holistic algorithms and machine learning and all kinds of things being thrown at these security issues. And so you need to be aware of all these different devices. You may need to use some of them on your network. You may go work someplace and they're there. And of course, you need to be aware of how to basically make sure that they're set up. And of course, then there's some best practices. Again, there are a lot of the standard ones. Do not use default passwords. Set passwords. Change. Make sure things are patched and updated. Test, on and on, all these basics, and there's a whole list of them there in lesson 3. So I won't spend a whole lot of time, especially since I'm running out of time, as I try to head on through the last couple lessons here. So let's move on at that point. So that was, all the different devices. So there's tons of devices. And then technically, of course, that's just network components. And I'm not talking about computers at all. Did I mention that? Those are things. I mean, they are. Almost all these are computers, right? Really, a router has got a heart, it's got a memory, it's got a storage. It may be flash, but it's got storage, it's got processor. I mean, your little router at home has got a web browser in it, web server on it. Many of them are actually based on Linux. If the truth be told, most of them are because of its open source and free nature. And so you're running basically a Linux computer in a router mode. It's kind of no different than BYOS, except you use a web interface to manage it instead of the command line when you really get down to it. And so, when we talk about those are network components too, but there's the servers and the workstations, and those are different areas of the 7 domains of the IT infrastructure. But they are network components to be aware of. They are, of course, technically they don't fall here, arguably because you can do them without a network. Most of the others, obviously, if you don't have a network, then why would you have intrusion detection? If you're just a machine by yourself, completely unplugged, you don't need intrusion detection. You don't need a firewall. But if you need a network, you need these components. And then the network, of course, is going to be a network of computers and servers and PCs doing their job. So what is it going to be a network of? Well, besides all those components, it's going to include devices running one of 3 major OS families, and that's lesson 4, operating systems. There are really today, when you really break it down, there are all kinds of flavors per se and versions, even in support. But for the most part, there are 3 major families. There's the Windows family of operating systems, which most of us know, well, I won't say love, maybe you do or don't. I'm kind of agnostic to all of them and love them all for what they're good at and hate them all for what they're bad at. And they all have their pros and cons. But nonetheless, Windows is ubiquitous still, especially as a desktop, especially in the enterprise, especially in big organizations. For years, they have been using Windows. Windows 7 is still hugely installed in the commercial world. 10, of course, is taking over, and they've taken a play out of the Apple book that they won't be changing. It's supposedly going to be Windows 10 forever now. I figure someday they've changed their mind and renamed and renumbered multiple times, so they'll probably change again someday. But now it's an OS, and it's a family of product, and you supposedly get updates for free, just like on the Mac side. But Windows is its own family. There is mobile or embedded versions of Windows, so that you can run an embedded system. So in other words, a stripped down version of Windows that you can run on lighter devices, like theoretically an Internet of Things kind of device or an embedded manufacturing type of system or device. Not as popular as, say, Linux in that capacity, because it's even the embedded Windows is bigger. Windows is kind of a little heavy, especially on the truly GUI side. It's a lot of graphics and overhead. The Windows 10 does seem to me to run mostly better. It does have some security and other issues with regard to the information it shares and things like that. But the Windows family is pretty straightforward. Most of us understand it. And there are also the Windows Server lines, Windows 2008 all the way up to the most recent versions. Heck, Windows 2000, Server 2003s are still out there. And they're sort of at the level of Windows 7. Of course, there's some of those are retiring or being retired, like XP retired a few years ago. Someday 7 will be retired. I think that's coming up, even though it's on extended support now, mainly because a lot of businesses haven't made the jump to 10 yet, and it's been slow adoption for Microsoft on that front. But you need to be aware of the Windows families. Of course, the Apple family is the other big family, in which we've basically had these two. We've actually had these 3 all along, but the 2, even from the early days, that would have been the fight, was the Mac and the Windows. We had commercials for that for a while, and for years, of the Mac versus Windows. And so the other side is the Apple. In the early days, early days, Mac had its own unique operating system that was truly its own. And in the earliest days, it was actually arguably better at multitasking than Windows was. But that was back when we used a model called cooperative multitasking. And I think Apple got it better back then, back in pre-OS X kind of stuff, way back, Mac OS 9, OS 7, and got the old Macs. And we're talking like when early Windows stuff wasn't very good at it, Windows 3, Windows 3.1.1, Windows 4 groups, whatever. So, but over time, of course, Windows has continued to progress along and move their family, and they have security and other issues being the popular platform, but they've gotten better, and they do a lot of things pretty solidly, networking and other types of stuff all throughout their history. And multitasking has actually been pretty good, but Mac has gotten better again because a number of years ago when Mac switched to, well, they first started calling it OS X, but now they call it Mac OS. But regardless, basically the 10X level, funny enough, coincidental that Windows 10 is stopping there too. It basically the 10 level of their major revision cycle. They stopped they changed, and now the Macintosh OS is actually a Unix-based OS. We still treat it as a separate family because Macintosh does a number of things, even at the very low level, but they do use a Unix core kernel. It's a mock kernel is what it's called, but either under there, it has some similarities. But because it is so different and unique in everything else they do, especially in the graphics side, it still gets treated as this completely separate family, even though it has a little bit of tie to our last group, because of now it is underneath Unix. As a matter of fact, if you have a Mac and you've never opened the terminal on it before, now that you've gotten this far into the program and have learned some basic little Unix commands, open up your terminal, take a look. You'll be able to take a change directory, take an ls, ping things, and it'll work because your Mac really is a Unix box underneath. But it has, of course, its Mac OS GUI, and it's a functionality, and of course its own suite of tools in the App Store and Safari and on and on and on. And this is the Macintosh world. And of course, the Macintosh world does extend though. Technically, I said there's like a embedded Windows. There used to be a Windows Phone, but there's not really anymore. Or it's dying on the vine, so to speak. But Apple has gone further. Apple, and they are actually heading toward even more unification of their various OSs. They actually, in a sense, have 4 operating systems. They have the Mac OS just for their laptops and machines. They have iOS, which is for phones and iPads. They have WatchOS, which goes for the new watches, of course, newer watches. And they have tvOS, which goes for their Apple TV products. Now, these are all based on a core Unix kernel, and they have a shared underlying core of technology, but they each focus. But they are moving toward having a unified platform for all of their devices, even more so than they do now. But that is the second major category. The third is a little more forced together, and as I mentioned, there technically could even be some overlap, arguably, between number 2, the Apple one. But that is what we call the Nix world, *Nix. Just basically any Li Linux in it or Unix. And there are still Unixes out there. There are Unix flavors, and Unix. One of the main reasons Linux was born was because Unix is a very, very powerful. The whole family is a very, very powerful language and operating system, and multi-user, prevented multitasking, etc. Very, very powerful system. Its problem was that there were only so many people who owned rights to it. AT&T, had built a kernel. Other people, Xerox, other companies in the early days, HP, certain people had flavors of Unix that they built. Sun Microsystems had Solaris, and they were usually pretty expensive. to license to run on a workstation for a high-end engineer. Say you weren't going to run that, you were going to run Apple or Mac on a desktop for your salespeople or average employees, but at the higher end, designers, machine simulations, different things, number crunchers, you might have had a Spark, a Solaris system with running, a Sun Spark system running Solaris, or an HP UX, or many people. One of my first Unix exposures was on some of the early little mini computer mainframe, little mini mainframes that would run inside of small companies back in the day. And these things would basically, how people would have, instead of having computers, they had dumb terminals. Like a bank might just have their own mini computer, mini mainframe running like an AS400, AS500, whatever the different lines of the IBM minis were. And they ran a Unix operating system. And then they would string, basically cabling for keyboards and mice. And you would go to the bank and there'd be somebody there and they would take your money. But there was no box. There's no tower there. There was no hard drive. It was all running just terminal sessions back to that mini computer. And of course, now and many times you'll do that. You'll still see that. You'll see somebody on a Windows machine, but they've got like we do in GNS3, we've got a shell prompt open. And but then they're connected to some old mainframe system, still plug it in. I think Fry still uses one of those. I was looking over the computer shell when they were doing a search. They seemed to bring up an emulator, a terminal emulator, and connect it into something. So I assume that's still some kind of system like that is powering their inventory system for search. So, but Unix was very powerful, but usually pretty expensive to license. And so people, including Linus Torvalds, who wrote the Linux version and other clones that are out there, the Unix-like operating systems, a number of movements started that ultimately led to Linux and then all the flavors of Linux since, because they're all open source. The idea was to clone that, to make as close to and not have any copyright issues, to have it so that it was totally open source. And that's why you now see so many different flavors. I mean, today Ubuntu may be the flavor of the week. It was Red Hat years ago. It was CentOS for a little while, it seemed like. Ubuntu seems to, I've seen a couple other flavors come and go over the years, and they're all out there. SUSE was popular for a while. That was the other one I was trying to think of. All these different flavors of Linux, and they all use the same kernel, and then it's a matter of what they build on top of it. And of course, you can take it yourself and make your own distribution. That's what Kali did. They took a Linux distribution and put a bunch of security products in it, and testing and penetration tools, and we'll play with that more, of course, through the program. But those are just Linux distributions. And so the Linux family has actually gotten huge for two main reasons, and it to where it's inarguably somewhat more important than either of the other two, despite Windows' huge history and still installed base on the workstation side. And that is because, as I mentioned earlier, in cloud, the vast majority of these VMs running in the cloud are running some flavor of Linux. It's free. It doesn't cost anybody any money. So why would you pay anybody when you can use a free VM, right? Just pay for the processing that you're using. So the Linux has taken off. There was estimates, I haven't seen a recent, so I don't know how recent, but not too many years ago, it was estimated that 60, 70, 80% of all web servers in the world were running on Linux servers. And I believe the number is still as high, if not higher. And you have a lot of other things. Lots of the games you play on your phone, they're talking back to a Linux server when they're sharing that data that's going back and forth between as you play your moves, and they're powered by Linux database servers, basically. But then you look at the other side, Android has taken off and is the number one installed, even though it's fragmented because of so many different variants, but the number one installed mobile OS in the world by a long shot. There are way more Android devices than there are iPhones because it's based on Linux. Google wrote it and then pretty much gave it away, as long as you ideally built their stuff in. But even people like Amazon, who don't include the Google Play Store and who do not, the Amazon Kindles are using Android. They're just not using the Google part of it. Google makes it easy for you to just use theirs. And so most providers, if you get a phone from somebody anywhere in the world and it's got Android, it's going to have all the Google stuff. In Amazon's case, they didn't want it. They wanted to have their own ecosystem, so they stripped out that stuff and made their own version of Fire OS, they call it. But it's Android. It's based off of Linux, so these things have just grown. So it's important for you to know these different families, how they relate, and then the types of devices they power, because you will see them and you will need to defend and protect them. Now, I'm running out of time, so I'm going to, it looks like I'm not going to get much, but I'm going to spend my last few minutes beginning to talk about programming. I don't know the few of you who made it into this section this time, for this pass at system administration. This is one of the, it may be your first experience with programming. And so, like I said, I don't mean to scare you by saying shell scripting is programming, but it is. And so one of the first things as you read through that lesson that I'm going to take you through in there is we're going to take you through some basics of programming. Things like syntax. What is syntax? Well, syntax is just the rules of the language. When we speak English, there's rules. You know, I before E except after C, that's a spelling rule, but you get my point. No untangling participles, all those. I never was really that good at English, to be honest, especially the rules of it. My wife's a genius at that. So we joke that I ask her all those questions and I do all the math or technical questions and we have a good team. But there's rules. And if you learn another language, then they have rules of where the verb goes and all this kind of stuff. That's the syntax of speaking. Well, programming is just speaking to a computer. And actually, to avoid having to do what we did in the earliest days, and actually, if you really want to understand how, at least get a glimpse of how the earliest sort of programming started and how the earliest sort of single, there's actually some videos out there. I used to show them in some of my classroom-based classes that I've taught in the past. But there's some various young people out there who have literally built working 8-bit processors inside of Minecraft. Now, this really gets you understanding at a deep level how bits and binary works. And if you understand Minecraft, you know the games are built well. So he used the spark, the fire flame block that can sort of carry a charge to build this device. There's a number of them that have been done. They're fascinating videos to watch. But I remember in the case, the person in his little character, his avatar, he would literally go up to these places, and if he lit the torch on fire, then that was a 1 for binary 1. If he left it unlit, then that was a 0. And he could go to 2 different banks that he had of those numbers and light up the fires, and the fire would go do its stuff and trace its flow through and go into the processor, and then it came back and lit up a different set of, and that's what a computer does. It takes zeros and ones and does math and comes back with an answer. And of course, all of that gets built into all the fancy streaming. I mean, this is gazillions of to track all the pixels. It's been converted on my computer, streamed out the internet, and then put up on YouTube for you to watch later. There's just trillions of these little bit, all about zeros and ones. At the various level, that's all a computer does is a whole bunch of zeros and ones. And so we don't want to program computers with zeros and ones. Oh my God, wow, that's a cool video to watch. And it's neat that he can say, okay, let's turn on so many bits and we've made number 3, and then we come over here and we turn on these bits and we've made number 4, and then it's going to come by and do the math and give us the lit up bits for number 7. That's what a computer does at the lowest level. That's cool to see that. But we don't want to program that way. I don't even want to program an assembly language, which is one of the lowest level languages anybody still pretty much writes with these days. And that's usually people who are writing like BIOS drivers and very low level stuff. So all of us instead use some other language. So syntax is just the rules of that language. Can you capitalize things? Can you not? Can you use spaces? What's the pattern of how do you declare certain functions? What are the keywords of that language? If it already has words for doing certain things, math or statistics, then you can't use those words in other parts of what you're trying to tell the computer to do because they're already keywords and it'll interpret them that way. So you need to learn the syntax of any language. You need to learn the basic rules of programming. Excuse me. Basically, all you're doing is line by line telling, at its simplest form, that you're telling the computer what to do. And that's what we're ultimately doing. And then we have the concept of variables, one of the most difficult people to grasp. So I wanted to, in my last minute or two here, talk about those things. And then next week, we'll cover some more. I'll do a little shell scripting demo and we'll rock on through the rest of it. But the variables allow us to write programs that have more functionality. And what it really comes down to is, if you think about something as simple as a login, you go to Facebook and you put in your username and your password and it lets you in. Well, if Facebook had to write that literally, like they had to have in the code, if Lee McWhorter, whatever password, then let him in, and they had to go update that every time a user was added, they'd have some, which they obviously do, they have a user list somewhere, it's a database though, of all their usernames and passwords, but they'd have to update their code all the time. And that wouldn't be efficient at all. Every time somebody signed up, they'd be adding somebody else into the programming code just so Facebook would run and that login would run. No, they don't do that. they use a variable name. It might be $user, $PW for password, or it may be spelled out. Capital U, username, capital P, password. Whatever language they're using to write it in, if it's whatever programming language that is, they're going to follow the syntax, but they're going to use a variable. And that way they can write the program something like this. If the username that's provided, the variable, whatever the user types in, I don't have to hard code it. I can just let whatever comes in matches against some username from a database, then we succeed, we let them in. And I've written this routine now in a few lines of code that basically says, if what the user put in this box matches what's in that database, and what this is in this box matches what's in that database, let them in, and if not, throw an error. And I've been able to write a few lines of code with some if then, and either redirect them to the main page or redirect them to the error page. And then I don't care how many users they have. And that's exactly what they did. And that's what we do with any program. And you're going to see as we take you through these exercises, and if you get that far before next week and start playing with it, you'll probably be able to work it out. It's not really that hard if you get past any internal fear you may have of programming and get the basic concepts down. Because basically you're just instructing, and shell scripting is the easiest place to start, because almost everything you do in a shell script, you literally could type at the command line and it would work. And technically, that's what you could do. You could just, and so what we do is we just take a bunch of those that we want to run and we put them together. And so we do some fairly simple examples of, copying files and doing this and that. But then you start thinking about, now you got the basics, then you can run with it. Anything you need to automate, like the example I talked about in the very beginning, why we even brought it up. Oh, sure, I know how to use the add user command in Linux. We learned that last, add a new user to our server. Or I know from some other program somewhere how to use Windows. I'm going to add a new user to Windows Active Directory. And then the boss says, we just bought this company. There's 10,000 people. And you're going to spend the whole next whatever hours, at a minute per 2 minutes per user doing that. No, you're going to write a script that'll issue those commands and maybe even import that from like a spreadsheet or something. And then let that thing run, and then all those users get created for you. And so you can begin to see, once you get the basics down, that then the power of it lets you automate so much. So that's where I'm going to have to leave off. I've actually gone a little long, but this is the first time in a little bit we've taught this session, and I wanted to make sure we got that much covered. I'm going to stop this for now because I've been going at this for hours. I'll start working on getting them all downloaded and posted. So in a little bit later tonight, this will be available, as well as the earlier lectures. Next week, we'll pick up with some examples of some shell scripts, and we'll rock on with the rest of it. Thanks a lot. See you next week.